Irodov problem number 1.64. The inclined plane of figure 1.11 forms an angle alpha with the horizontal. The mass ratio m2 by m1 is given as eta 2 by 3. The coefficient of friction between the body m1 and the inclined plane is equal to k. The masses of the pulley and the threads are negligible. Find the magnitude and the direction of acceleration of the body m2 when the formally stationary system of masses start moving. So, let us draw the diagram first. This is m2, m1, alpha, coefficient of friction k. Now, this problem is very similar to problem 1.63. I will link up the solution on the board. We will be using a result that we obtained in the solution of 1.63 to solve this problem. So, the results that we obtained are m2 will go up, will accelerate up if the ratio m2 by m1 is less than sine alpha minus k cos alpha. And the other result that we got was m2 will accelerate downwards if m2 by m1 is greater than sine alpha plus k cos alpha. If the value of m2 by m1 is between these two values, then the system will be stationary. Okay? So, in this problem, alpha is given as 30 degree, m2 by m1 is eta is given as 2 by 3 and k is given as 0.1. So, let us calculate these two values. Sine alpha minus k cos alpha be sine 30 degree is, let us write it down. This comes out to be 0.4134. Okay. Now, m2 by m1 is 0.67. So, m2 by m1 is greater than sine alpha minus k cos alpha. So, therefore, m2 will accelerate downward. Okay. Let us say it accelerates with acceleration a. Okay. So, now that we have this, let us draw the free body diagram for m1 and m2. So, m1 will be, we have m1 G, we have tension force like this, we have a normal reaction like this, and since m2 is going down, m1 will go up. So, friction force will be opposing the direction of motion, and this is accelerating with acceleration a that way. For m2, it will be simple, m2g, tension force, and it is accelerating downward with acceleration a. So, now from both of these we can write Newton's equations of motion. So, from this we can write T minus F friction, and also this angle is alpha, minus the component of m1g in this direction. So, that is m1g sine alpha is responsible for acceleration of m1. So, m1a. Okay. So, from this one we can write m2g minus tension is equal to m2a. So, the only unknown is tension. So, we have to use these two equations to get rid of tension. So, how we can do that is we add these two equations. So that becomes m2g minus f, t's get cancelled out, minus m1g sine alpha equals a m1 plus m2. Okay. Now friction is K times normal reaction, because this is kinetic friction. So K times normal reaction is m1g cos alpha. So we can substitute that. So let's bring a m1 plus m2. So that will go in the denominator. And this will be m2g minus friction is K m1g cos alpha minus m1g sin alpha. Okay. Now if I divide, so g we can take common. If we divide numerator and denominator by m1, so we have m2 by m1 minus k cos alpha minus sin alpha divided by 1 plus m2 by m1. Now m2 by m1 is given as eta, so we can further simplify this as eta minus k cos alpha minus sin alpha divided by 1 plus eta times g. Okay. So acceleration will be eta minus k cos alpha plus sin alpha 1 plus eta times g. If you substitute all the values, we have all the values, this will come out to be 0.05 g. Okay. So that's our solution.